Hello, I'm Aaron Lohr, and this is the Endocrine News Podcast. We all know the saying, nothing lasts forever. Whether it was your first car, your favorite sweater, or leftovers from dinner, everything is going to break down, fall apart, and or decompose, right? Well, maybe not. There is a group of chemicals known to have endocrine disruptive effects called perfluoroalkyl and polyfluoroalkyl substances, oftentimes referred to as PFAS or Pfas. While they do break down, it's so slowly that they've been called forever chemicals. Where can PFAS be found? What exactly is their effect on human health? What are manufacturers doing to limit exposure, and is it enough? Excellent questions, and here to help answer them is Dr. Benson Akingbemi, a professor at Auburn University. Dr. Akingbemi and his colleagues recently published an article in Endocrinology entitled Legacy and Emerging Perfluoroalkyl and Polyfluoroalkyl Substances Regulate Steroidogenesis in the Male Gonad. This article is available for free as it was part of the Endocrine Society's thematic issue on men's health, and we'll provide a link in today's episode description. Dr. Akingbemi, thank you for being here today.
Thank you for having me.
What are PFAS? Where can they be found, and why are they considered forever chemicals?
PFAS are compounds which have been used in the manufacturing of a variety of consumer products. For example, they are found in the manufacturing of cookware, found in some cosmetic products, and in particular, they are a major and important constituent of flame retardants. Flame retardants are used heavily around airports and on military bases. Populations living around those locations are apt to be more exposed to these chemicals.
And when they're referred to as forever chemicals, like forever, or almost forever, what do we mean by that?
They are called forever chemicals or persistent organic pollutants, simply because they have these tendency to persist in the environmental space for a very long time. Now, the implication of that is these compounds are still there in the environment, meaning that the population is continuously exposed to PFAS even when sources have been stopped for a while.
Wow. They're around in a lot of places. They last for a long time, so some people might be concerned. How concerned should we be? What do we know about the impact of PFAS on human health?
We should be concerned because from data in the literature, we now know that virtually every segment of the population has PFAS in their blood, in their tissues. There have been studies from within the United States, from abroad in the Scandinavian countries, measuring PFAS levels in mothers and infants and babies and adults. And of course, PFAS is a generic term. Virtually, there are so many compounds which form part of this PFAS classification that we use. These are measurable. These are present at measurable levels in the blood of several segments of the population. So exposure of the population is very significant.
So there's a lot of exposure, and what do we know about that exposure as it links to particular health conditions? What sort of things might that be associated with that would be considered like an adverse reaction?
Several epidemiological studies have measured PFAS levels in the blood and tissues, and there are associations between PFAS levels and several biological consequences. Although these are associations, PFAS levels have been known to correlate with pregnancy and pregnancy outcomes, have been connected to development of metabolic syndromes, have been associated with some cancers, especially reproductive cancers, have been associated with immune disorders. So there are a variety of health effects which have been associated with PFAS in the body. As I mentioned earlier, these are associations simply because when we measure these compounds in humans, You have other compounds possibly in the blood, and therefore the best you can do is to do correlations between PFAS levels, perhaps individual PFASs, and certain health outcomes.
We know that PFAS is all around. It seems everybody has some in their blood, and they're also connected or associated with some adverse health outcomes. And it also seems there's some agreement on these risks from the manufacturing industry and that they've made some changes. Specifically, the industry is moving from using long chain PFAS to using short chain PFAS. What does that mean? And why would short chain be possibly better than long chain?
One, the Environmental Protection Agency has in recent years been active at asking manufacturers to reduce the levels of PFAS in their products. So if you measure in the population now, there's a tendency to be measuring the old PFAS compounds in body tissues. But as you just mentioned, these so-called legacy compounds are now being replaced by a new set of compounds called emerging or replacement PFAS chemicals. And the levels of those are the ones that are actually increasing in body tissues. The manufacturing industry, too, in response to EPA guidelines, has been trying to remove the legacy compounds and use this so-called emerging or short-chain PFAS. The idea is that the short-chain PFAS have a less or a diminished capacity to persist in the environment. That would be a good thing because it means if you were to shut down an industry in a place, you have short-chain fatty acids persist to a much lesser extent than will have been associated with the old legacy compounds. Well, having said that, besides the persistence in the environment and the continuous exposure that will have arisen from the previous set of compounds, there is no conclusion that the new set of short-chain or emerging PFAS are less toxic at this point in time.
That's very interesting. And so there's been this change. The legacy compounds are being abandoned for these newer ones, these substitute ones, these short chain PFAS, but we don't really know how much safer or if they are indeed safer at all. But your study that we talked about earlier during the introduction actually looks at this a little bit. Can you tell us about your study and what you wanted to learn?
We and a number of other researchers have been now moving towards a situation in which we have to look at the toxicity potential of the new short-chain compounds. And so our study that was just recently published in Endocrinology attempted to compare a number of legacy compounds versus emerging PFAS. We compared PFOA and PFOS are the classic legacy compounds we had to deal with in this study, and PFBA and PFBS, which are the corresponding short-chain PFAS, were employed in the same study for comparison to see whether we can replicate the toxicity of the legacy compounds with the new compounds. We are biomedical scientists, so our model was the growing rat, male rat, because we are interested in the reproductive development and function. So what we attempted to do was to measure after feeding, we provide these compounds in the drinking water for the animals, and then after a period of time, we terminate exposure and then collect blood and the testes, and to measure reproductive hormones and then compare between the two groups. We also attempted to see whether PFAS compounds that contain carboxylic acid, that's one class of PFAS, and those that contain sulfonic acid. An example of carboxylic acid containing PFAS would be PFOA that we knew about before. An example of a sulfonic acid containing PFAS is PFOA, as we knew before. And the new PFAS like PFBA would be a carboxylic acid containing short chain, while PFBS that we also employed would be a short chain sulfonic acid containing PFAS. So we wanted to see if that is a factor in the toxicity of PFAS compounds. One other thing we also looked at was, which is classic in this area of study, given the fact that we are exposed to multiple chemicals, even within the class of PFAS, huge number. Can't tell you how many PFAS compounds there are. To see in a very limited way whether combinations between legacy, Pfas, and combinations of the newer compounds will produce the same toxicity, in that we normally expect what we call additive effects between chemical compounds when animals are exposed to a cocktail of chemicals, which is what happens in the natural environment.
Now, I'm sure everybody listening is very interested. You have this great model. You're going to see the toxicity levels of both and some other things. And what did you find?
Because we are reproductive biologists, we measured steroid hormones, which are the main drivers of reproductive development. In this instance, we are the reproductive biologists, and so you will expect that androgen secretion, which the primary androgen in the male is testosterone. So we measured the levels of testosterone in the blood and the concentrations that we find in the testes, which is the organ producing testosterone. We also given evidence the last 25 years showing that estrogen, which otherwise is the female hormone, is also critical to reproductive development in the male. So we also measured the level of estrogen that we could find in the blood as well as in the testes from these animals for comparison. And perhaps not surprisingly, the levels of androgens and estrogen that we measured in both blood and in the testes were affected by both classes of compounds.
Wow.
Legacy or emerging, or whether carboxylic acid containing or sulfonic acid containing. So we had these compounds regulate in a fairly, I would not say complex, but unpredictable way, that you have both an increase depending on the dose, which is a factor in these studies, or a decrease in the secretion of these steroid hormones.
Whether it was the legacy ones or the short chain ones, you found a negative impact in both of those. So if all the PFAS that are being used in manufacturing right now seem to have a negative impact on human health, and they are so ubiquitous, is there anything that can be done to limit exposure? What do you think next steps might be?
I think the whole idea of studying these compounds is to see how government regulatory agencies can use data from whether epidemiology or classic toxicology studies to find a way to regulate the levels of these compounds that present in consumer products. So there are a number of things. As I mentioned earlier, the EPA has diminished or decreased the amount of PFAS compounds in consumer products, and the manufacturing industry is also beginning to reduce or replace with new compounds, which, even though we are yet not too sure they are safer, but that's an attempt to respond to public health issues. The other thing that can be done is several monitoring, that if different segments of the population, whether infants or breastfeeding babies or individuals living around areas, like I mentioned earlier, military bases and airports, the population can be monitored. In that way, we can identify vulnerable segments of the population and find ways to mitigate their exposure levels. On the general term or practical level, there are technologies being developed to try and filter away, remove PFAS from sources of exposure, especially in drinking water. And I think there has been some progress made that's small, affordable. I think the approach would be to move towards affordable filtration media that's available to the public to remove these compounds from drinking water, which probably is the main source of exposure.
Well, it's nice to hear that, there are some thoughts about how to, make this better for everyone and limit the exposure, like with the filtration systems and things. When we think about PFAS, it's only one of many substances that are often referred to as endocrine disrupting chemicals. How much of a risk do you think these chemicals pose to human health? And do you think that risk is well understood? Do we have a good appreciation for the risk that these chemicals pose?
I would think so. In the last 20 to 25 years, the government has been more proactive in demanding or regulating that the use of chemicals in manufacturing should be more curtailed, should be more regulated. There have been instances in which sporadic cases, like the Flint issue, where lead was found in pipes, brought this issue to the forefront of public health. Before that, there have been reports from wildlife exposures, lakes, water sources that are polluted by chemicals, and animal sentinel species resident in there develop, these developmental anomalies over time. Those are reassuring that truly being exposed to these compounds is a major problem. Now, doing the same exposures in the laboratory setting hasn't led to dramatic signs simply because we cannot keep animals in the laboratory setting for a long time. There's a major difference between working in the field and working in the lab. But the lab setting provides a very great environment to identify the processes and the mechanisms by which chemicals would interfere with biological phenomena, because that is also important, that what the chemicals are doing to laboratory species, those biological pathways or processes also present in humans, so that we can extrapolate to some extent that if we can find these molecules or pathways interfered with or dysregulated in laboratory species, because they do the same thing in humans, we can extrapolate that exposure of humans to the same compounds will lead to that effect. So combining this evidence from the wild and biomedical research has led both government and the scientific fields to address these issues, and several countries are now beginning to limit. For example, Canada has banned the use of bisphenol A, which has been popular in the field, from manufacturing of plastics. The FDA in this country since 2012 has said if and products should not contain bisphenol A. So I think there is progress, moving on, that as soon as evidence accumulates enough to drive the process of regulation, government has been listing, but not just in the United States, but also in Europe. As you know, the Endocrine Society has a very strong group here for endocrine disrupting chemicals, as well as in Europe. And in the Scandinavian countries too, they have on their own also have a lot of monitoring that they do, and have been a major part of the global focus on endocrine disrupting chemicals. Yeah, it does take time, but I think the general population is coming to that realization. There is increased public awareness that exposure to chemicals, which in general behave like hormones, they drive a lot of body processes, and those will be very, very cause deleterious effects in the population.
It just also highlights how important it is to have good science out there like yours, and just how much we appreciate all that good science that's coming out to help inform some of these policy decisions that are being met. And also just want to say thank you for being on the podcast today. We're actually out of time, but this was fantastic. Thank you so much for being here.
It's been my pleasure. Thank you.
That's all for this episode. I hope you enjoyed it. If you're interested in hearing more about endocrine disrupting chemicals, I invite you to check out a recent article in the Journal of the Endocrine Society entitled Chemicals Used in Plastic Materials, an estimate of the attributable disease burden and cost in the U.S. This article includes findings that show endocrine disrupting chemicals in plastics cost the U.S. an estimated $250 billion in increased healthcare costs in 2018 alone. We'll link to the article in today's episode description. We'll be back soon with another fascinating dive into the world of endocrinology. Until then, thanks for listening.
Endocrine News podcasts are a free service of the Endocrine Society. To learn more or to become a member, visit the Society's website at www.endocrine.org.